a motion in two dimensions. We have to see the variation in the x-axis and also the variation in y-axis. Either the velocity variation with respect to x-axis and y-axis. Now, this is the projectile that can be fired with a certain angle. This is the path that is followed by the projectile. This is the trajectory. This is called as trajectory, the path that is followed by the projectile. Initially, when we fired this, it has some that has a theta angle in the x-axis. This is the velocity, initial velocity u, in which it was fired. It has certain angle theta, right? What will happen? We can split this velocity into two components for our convenience, because this is the motion in two dimension, but the particle will cover some displacement in x-axis, and this is the displacement diagram, right? Now the particle will cover some displacement in x-axis and also in the y-axis. Displacement distance graph बनाया, so we can also have the idea of that. The particle will cover some displacement in x-axis and some displacement in y-axis. And similarly, जब उसके displacement दोनों axis पे आएंगे तो उसका मतलब उसके velocity के जो variations हैं उनको हमने दोनों components में देखा है. But all the time उस particle पे जो gravitational field strength है that acts vertical downwards. At all the points particle के ऊपर जो आपका object है उसके ऊपर gravity is acting, but that gravity is actually acting in the uniform acceleration, uniform gravitational field strength है. That's why जब आपने इसको fall पहले initially देखा होगा तो v by component will be very high. So with the passage of time, that v by component will start decreasing. यहाँ पे v by बहुत highest value होगी और v by का component क्या होगा? Time के साथ साथ that starts to decrease. ये कम होता जाएगा और यहाँ पर at the maximum height, yes, if it is the maximum height, the v by component of the velocity will be zero. लेकिन दूसरे पार्ट पे जब ये यहाँ पहुँचेगा from this point, when it's coming down, again the v by component will start increasing with the time. Time के साथ साथ v by component क्या होगा? Increase.
जब ऊपर जा रहा है उसको पॉजिटिव के लिए नीचे डायरेक्शन.
नहीं, आपने थ्रस्ट जो डाला है ना, तो थ्रस्ट अगर वर्टिकल अपर डायरेक्शन पे नहीं है, यानी नेट वेलोसिटी अगर वर्टिकल अपर डायरेक्शन पे नहीं है तो ये ऑब्जेक्ट राइज नहीं हो सकता. There are two set of forces acting on the ball. क्या है? One is the weight, which always act vertical downwards. ये इसका path है. दूसरी जो net force है, that will be in the direction of this path. For example, अभी जो आपने thrust दिया है उसको, वो इस डायरेक्शन में. So अगर हम इसका resultant निकालें तो force का resultant somewhere here. ये resultant. That is the resultant force which is acting on this ball of the particle to move it in that direction. बात समझ रहे? अब इस पे दायरे air resistance भी act करती है. Here we are considering that there is no air resistance. Right now we have assumed there is no air resistance. The object is experiencing only the gravitational field strength. वो सिर्फ g की वैल्यू को एक्सपीरियंस कर रहा है. If it goes opposite to the gravitational field strength, उसकी v by component with the passage of time will start to decrease, and the maximum height the v bar will get reduced to zero exactly. और इस point के बाद जब particle आने लगेगा नीचे, the v by component will start to increase. Now, for this part of motion, we assume that A is equal to minus g throughout. This is the assumption. This is the convention that we have used. Why A is minus g throughout the motion? Because we have considered this direction as positive. If the particle is going and it's losing the speed in the positive direction, तो मतलब इसका deceleration हो रहा है. That's why gradient decrease हो रहा है. And this is what we have learned, right? इसके जो gradients होंगे वो क्या होगा? Decrease होने का मतलब है कि A की value minus g होगी. That's decreasing in the positive direction. और जब यहाँ से ऑब्जेक्ट वापस रिटर्न होगा, so that will be coming in the negative direction again. Now it start to gain the velocity or speed in the negative direction. Again, the value of a is minus g. So throughout the motion, the value of a is minus g actually. This is what we are thinking. अब आप अगर पॉजिटिव से नेगेटिव कर देते तो फिर कुछ और मामला हो जाता। तो पता है क्या इफेक्ट पड़ता है फिर? But here we have assumed that a is minus g. What I want you to understand, the first point you have to understand, in this motion, only the gravitational field strength, the value of g is going to affect the vertical velocity component में जो change आएगा वो g की वजह से है। g is responsible for this decrease in velocity and that increase in velocity in the y-axis. That is called the gravitational field strength is responsible for that. The first thing. Second बात यहाँ पर क्या है? Along the x-axis, the object won't experience any force. The horizontal component of the velocity is same throughout the motion. अगर मैं हर जगह पर यहाँ component resolve करके आपको बोलूँ कि इसका u x बताओ क्या है, तो that's constant। ये change नहीं होगा, इसलिए change नहीं होगा क्योंकि x-axis के direction में object is experiencing no force. There is no force along the x-axis. सिर्फ force vertical component पर act कर रही है, that is the gravitational field strength which is experienced by the object in the y-axis. x-axis पर कोई acceleration नहीं है. There is zero acceleration. That's why the velocity will be constant. dx आपका हमेशा क्या रहने वाला है? Constant रहने वाला है. So this is the horizontal velocity. ux is constant, ux is same, ux is same. That horizontal velocity won't change. Because the object won't experience any force in the x-axis. अब अगर मैं आपसे ये कहता हूँ कि इसके लिए टाइम टू रीच द मैक्सिमम हाइट के लिए इक्वेशन बनाओ, कितना टाइम लगेगा टू रीच द मैक्सिमम हाइट, इसके लिए ये इक्वेशन बनाओ कि टोटल हॉरिजॉन्टल रेंज ये कितनी कवर करेगा, मतलब जिस पॉइंट से मैंने इसको फेंका है दैट्स अ पॉइंट ऑफ प्रोजेक्शन, और जहाँ पे ये ड्रॉप हुआ, लेट्स सपोज यहाँ ड्रॉप हुआ, यहाँ वेलोसिटी की बात जीरो हो जाएगी, सिस्टम का ड्रॉप हुआ, सो यहाँ ड्रॉप हुआ, इस बीच जो डिस्टेंस आ रहा है दैट इज द हॉरिजॉन्टल रेंज ऑफ दिस प्रोजेक्टाइल, दैट इज rx. If I ask you कि आप rh निकालो, then you can calculate the horizontal range as well by applying the trigonometry, basic trigonometry design, because velocity has the two components. Now we can resolve the two components. Let's suppose this is the velocity v or u. If I ask you कि इसका x-axis में क्या component है, तो you will apply the basic trigonometry और आप इसको जो है ना वो base upon hypotenuse, मतलब base में मुझे ux चाहिए, ये component u का इस जगह पे चाहिए. So how can I get that? I would say that base to hypotenuse, तो base आपका ux है, hypotenuse आपका u है, is equal to cos theta. So what is the ux? X component of the velocity. That will be u times cos theta. जो भी u की वैल्यू इनिशियल होगी, लेट्स सपोज मैं इसको एग्जांपल से भी लिंक कर देता हूं ताकि आप कैलकुलेशन भी करते रहे साथ साथ. You can write that initial velocity is 20 meter per second when I drop that object and it makes an angle of 30 degree with the horizontal axis. If I ask you what is the horizontal velocity, इसका ux बताओ, so what will you do? You will take the 20 multiply by cos 30. That will be the component of the velocity along the x-axis. I mean ux निकालना है, so I can plug in the value of cos 30 into 20 will give you the answer for the component of the velocity along the x-axis. If I ask you vertical component निकालो, so this is the vertical component. Vertical component जब निकालेंगे तो ये एंगल का opposite side है, which is the perpendicular, और hypotenuse इसका u है, so we can write कि ये component perpendicular is ui, so I can write ui over that is u is equal to sin u. तो इसका मतलब y component ui is going to be u sin u. This is the vertical component of this velocity. This is the horizontal component of the velocity. Sometimes what we are going to do, we are given with the horizontal and the vertical components of the velocity, और हमसे पूछा जाता है what is the resultant velocity of this particle. So we can also calculate that by applying the Pythagoras theorem. ये एक right angle triangle है जिसके अंदर ये y component is u sin theta और जिसका x कंपोनेंट जो है वो u cos थीटा है और इसका रिजल्टेंट जो है वो हमारे पास u है। तो we can calculate this hypotenuse by applying the right angle triangle, मतलब hypotenuse का स्क्वायर और पर्टिकुलर का स्क्वायर प्लस बेस के स्क्वायर के इक्वल होता है। We can take the square of all the values, u sin थीटा का स्क्वायर u cos थीटा का स्क्वायर, और ये जब अंडर रूट में सॉल्व करेंगे तो आपको ओरिजिनल वेलोसिटी मैग्नीट्यूड और वेलोसिटी पता चल जाएगा, जिससे आपको उसको फायर करना है। अभी मेरे बात पूरी नहीं हुई, एग्जांपल मैंने साथ कोट की है सो दैट वी कैन डू द डिटेल वर्किंग ऑन दैट। सबसे पहला काम, इफ आई आस्क यू टू कैलकुलेट टाइम टू रीच द मैक्सिमम हाइट, टाइम टू reach the maximum height, what time the projectile will take, what time t it will take to reach the maximum height, इसको solve करना है in term of u and g, time to reach the maximum height। अब देखो maximum height निकालने के लिए we have derived the equation of motion, उसमें हम आराम से उसको लगा सकते हैं। Initial velocity, you know that initial velocity, ये तो vertical height gain होगी ना, ये v by component की वजह से gain होगी। Remember my keywords, remember the keywords, what are the keywords? Vertical height is gained by, vertical height is gained by, vertical height is gained by v by component, यानी वो जो u by component है वो रिस्पॉन्सिबल है वर्टिकल हाइट गेन कराने के। जितना ज्यादा v by component होगा उसकी हाइट उतनी ज्यादा बढ़ेगी, यानी वर्टिकल जो हाइट आ रही है आपके पास that is gained by the v by component। v by component is involved because we have divided the motion independently into two axes। u by initial अगर velocity u है तो उसका v by component में इसको u by बोल दें, सिंपल है, और v by whatever you like। टाइम टू रीच द मैक्सिमम हाइट पे पहुंचने के लिए we assume that the initial v by component of the velocity, if I want to calculate how much time would it take to reach the maximum height, so simple is that I will take the u which is 20 and I will take sin 20 and I will divide this value by 9.81, that will be the time to reach the
So 1.44 seconds.
अब total time of flight in the absence of air इसका डबल होगा, जितना टाइम इसको यहाँ लग रहा है जाने में उतना ही टाइम it will take to reach this point। Total time of flight will be 2 time of t and that is equal to 2 time of 1.44। So what's the total time of flight? It will be
1.4. Oh, sorry.
2.8.
2.4. 2.88.
It's 2.88. The velocity v by v is 0 at the maximum height। If you will reduce the v by 0 तो minus u sin theta का पूरे का स्क्वायर ले लेंगे। Take the square of this and this minus 2g है, minus से minus again that will be cancel out, ये वापस cancel out होगा and now I can write 20 into sin 30 and taking the square of this and divided by 2 times of 9.81, again you will get the same answer as you have calculated by this equation। फर्क सिर्फ ये है कि this equation has the time and this equation is independent of time, सिर्फ ये फर्क है, बाकी आंसर सेम है। Now the another part is how can I calculate the horizontal range covered? So which component of the velocity you are going to use when you have to calculate the horizontal component? You will use ux, right? जब horizontal range की बात होगी, what will you use? ux। जब vertical की बात होगी तो ये बात range से नहीं निकलनी चाहिए। This is the key logic for this topic। अब मैं बोलूँगा horizontal range चाहिए, I will say that I have to use the ux। So simple, क्योंकि speed doesn't change in the x-axis, so I can apply the logic। Simple formula: speed is equal to distance over time। This distance is the horizontal range. This is what I'm asking। This is horizontal range is the distance divided by time taken will give you vx, which is the horizontal component of the velocity। Because constant, that's why this formula can be applicable। अब मैं बोलूँगा what time we are going to take if we need this distance, so you won't use this 1.44, you will take 2.88। अगर 1.44 लोगे तो ये हाफ रेंज आ जाएगी, ये हाफ डिस्टेंस आ जाएगा, but we don't need it, we need the full distance। I mean horizontal range मेरे पास पूरी आनी चाहिए। So the total time of flight जो मैंने निकाला है, I have to take this total time of flight in order to calculate the total horizontal range उसकी जो point of projection से जहाँ पे वो land करता है उसके बीच का पूरा distance आ जाएगा if I will substitute the value of total time that are taken by the particle. So what I can do, I can write Vs component was u cos theta. That was 20 multiplied by cos 30 into 1 2.88. So that is the horizontal range. That is Rh. ये मेरे पास है.
15 meters.
What's the distance?
15 meters.
50 meters. In the next class, I will start.